So what I thought I'd do is, oh great. So what I thought, given the breadth of the audience, I thought what I'd do is sort of give you a general perspective of NSF. Talk about gateways for sure, but also talk about our software programs, but also try to give you a little bit of insight into our internal thinking. So because all of you will be interacting with NSF at some point in your careers, right? You're having that kind of insight will help you in this. So I thought I'd begin by sort of explaining who I am. So every program officer is different, every program director is different, they come with different experiences and expertise. And I thought giving you a sense of my experience and expertise and background sort of would help you, inform you on the lens by which I see things. So let me start with that. Then I'll talk about NSF and what it thinks of infrastructure and then cyber infrastructure and what my division, which is the Advanced Cyber Infrastructure division, plays in it. I'll talk about my particular responsibility, which is the software CI programs. I'll talk about, give you just briefly at the other CI programs, and then we'll spend a little time on gateways and give you my impression of looking ahead. Okay. So interestingly enough, I studied at the Ohio State University. At that time, it didn't have the B. It was just Ohio State University. I'll tell you that much. The moment I left, they added the B. And my research was essentially in integrated development environments for distributed systems. So environments that allowed you to specify systems that were collaborations of processes that were distributed across the network. And then interestingly enough, I left all that behind and worked in industry for about 11 years, and we basically built collaborative workflow products. So not the kind of workflow like Pegasus and so on that does job scheduling, but where humans collaborate together to accomplish some kind of a goal. And I was, I led the software product development aspects of it, and for a brief period, I was also the chief technology officer. And the kinds of workflows we are talking about is, purchase order to engineering design. We did some work for the orthopedics department of Ohio State for selecting joint replacements for various knees and hips and things like that. The extrusion processes, the clean room process for software design. We were deployed at Lockheed Martin for doing their land management in South America, in Caterpillar for managing all their technical documentation, Washington Mutual, their loan application processing, and then for, at Allison Gas Turbines for, again, engineering design management. And then we came up with something like Lotus Notes, which we call Track It for just, office collaboration. And a lot of that started off with SBIR, STTR kinds of funding. Then we started we were part of some federally funded consortia, the NIP consortia, the Workflow Management Coalition, and, before OMG was, oh my God, it was the Object Management Group. And we were there. And then I ended up at Ohio State. So this was a SBIR-funded defense R&D kind of company. They made the transition to a commercial company. We became part of a company called Computer Vision that made all kinds of CAD software and so on. We were the workflow bus underneath. When Computer Vision sold off, we did a spin-off and we became a startup. And then, after the startup became a shutdown, I ended up at Ohio State. And here I'm a professor of practice. I do a variety of, industry university collaborative kinds of things, application-based things. I did a little bit of business development as well for the Ohio Supercomputer Center, and then was involved in creating a lot of the courses that were aimed towards professional practice, preparing students for industry jobs and things like that. And before I came to NSF, I did a lot of outreach and consulting as well around enterprise architecture, around software engineering processes, was on advisory boards of a few companies, things like that. Okay, so that's sort of my background. And my cyber infrastructure relevant experience is actually, or at least science cyber CI experiences, is a little bit indirect. Okay, so it was part of this whole NIP consortium where we were looking at internet technologies for advanced manufacturing. So the idea of connecting your ERP system that is releasing product specifications down to your shop floor that's actually doing the manufacturing. So we were involved in things like that. When I was at OSU, we put together probably the longest sensor network. It was a 2-mile long sensor network for intrusion detection. was part of the NSF Genie project, and then a cyber learning project that was NSF funded, some industry big data projects, and they are the ones that fund my students today back at Ohio State for fraud analytics and customer retention, telematics, expert finding. And then with the Ohio Supercomputing Center, periodically I would help advise the Supercomputing Center on the software engineering aspects of the portals they were developing, which were called portals then and not gateways, but that's really what they were. And then later I dabbled a little bit in business development, trying to get these portals adopted by small to medium enterprise. Yeah. Right? So my take on cyber infrastructures is that they essentially enable ecosystems. They enable ecosystems of industry, they enable ecosystems of science. That's what they actually do. And in pretty much all cases, the people who fund the creation of these cyber infrastructures are essentially investors seeking a return on investment. Okay, and the expected the return might be commercial, it might be return in science, might be in education, and then ultimately in economic development. Okay, and when I came to NSF, I was quite struck by the fact that thinking existed in NSF too. Which is that we're essentially an organization that funds 1,000 points of light, funds research, right? This notion of funding infrastructures that are there for long term is a little bit out of the norm for NSF. Okay, but this is true everywhere. Anybody who funds these kinds of infrastructures are really looking at them as ways of generating commercial activity or other kinds of return on investment. That's what they're looking for. And the key to return on investments are cyber infrastructures that are somehow sustained by their ecosystems. Okay, and gateways are a great example of that. So let me now talk about NSF. So once again, the reason I brought up my background is that's the lens through which I look at things. The way I look at projects, the way I look at proposals, all of those things. And it's important to understand for each program officer how he or she looks at those things, okay, for those who write proposals. And it's also important therefore it's also important to get to know your program officer, visit NSF, talk to them, things like that, okay. The other thing is each of us looks at it from our lens, looks at things from our lens. We don't understand the other lenses completely. So it's really important for you to share your perspectives with us so that we can appreciate where you guys are coming from and what your constraints are and what your capabilities are and all of those things, okay? So going on to NSF. So NSF thinks of infrastructures very broadly, starting from colliders to radio telescopes to ships to regular telescopes to seismic sensors to sensors in the sea to satellites. And essentially, NSF thinks of cyber infrastructure as the computational aspect of these larger infrastructures. Okay, so that's the first thing. So we think very broadly in terms of infrastructure and in terms of cyber infrastructure. So ACI, for example, supports facilities as well, in addition to computational kinds of facilities like Comet and Exceed and so on. NSF views cyber infrastructure as driven by research priorities and evolving with the scientific process. In other words, we don't try to guess at what cyber infrastructures are needed. Okay, we look to the science community to sort of tell us what the science drivers are, what they're planning to study, what the advancements that are needed, and we try to put together cyber infrastructures in support of them. Okay, and as these science drivers and these areas sort of evolve, we try to evolve these cyber infrastructures in support of them as well. Okay, so we are very, in a sense, driven by community needs. Okay, and we think of cyber infrastructures as a combination of software, of computational resources, scientific instruments, the data, the networking, and all of that, but also the people and organizations and communities that are supported by the cyber infrastructure and that use the cyber infrastructure. So we're concerned about all of those things. Okay, and we are really active in seeking community input and learning from their experience. So there are these periodic National Academy of Science studies. There are task force reports. There are vision documents created that are all public, by the way. So please go ahead and read them. That sort of inform us as to what we should be doing. A lot of these are at a very high level, okay, and so there's a lot of initiative we can take within that high level direction, and that initiative we take is actually driven by things we learn by talking to you. Okay. So going now into one division within NSF, which is the Advanced Cyber Infrastructure Division. Here's kind of how we are structured. We're structured in essentially 5 clusters. There is the HPC cluster, there is the data cluster, there's the networking and cyber security cluster, and then there's the software cluster, which is me and Vipin Chaudhary at the moment. And then there's the cross-cutting cluster that looks across all of those, and that's the learning and workforce development cluster, right? And we call them clusters even though there's usually 1 or 2 program officers in each one. But you can be a cluster of 1 if you're really good. So Sushil, for example, is up here, and he essentially runs all our educational kinds of things, careers, REUs, things like that. Okay, and even though we are broken up into clusters, because that's where you need specialized. In each cluster requires some kind of specialized knowledge. We interact a lot, we talk a lot, we meet pretty much every day to think about things. So we are quite integrated. Even if sometimes our solicitations don't appear so, we do exchange a lot of information to try to see how we can leverage each other. We do a fair bit of co-funding. We use language from one solicitation in another. We try to do all of that. Yeah. And these clusters interact with NSF directorates, with NSF-wide initiatives. We interact with industry agencies, all of those things. So when you talk to somebody in one cluster, you're essentially talking to all of ACI, in a sense. Okay. In fact, something that we've been trying to do now is when a PI visits NSF and wants to talk to a program officer, we try to get all the program officers to come talk to him or her at the same time. Okay, so you get all the perspective. So our challenge, the challenge that we see within ACI with respect to cyber infrastructure is that we have all these disparate things. We have facilities, we have collaboration networks, we have clouds, we have national computing resources, we have shared data and software, all of those things. But all of them have to be put together in a way that advances the productivity of the researcher, of the research group. Okay? So that integration challenge, that usability challenge is the thing that we are most concerned about. We know we can provide horsepower. The question is, how do you channel that horsepower so that the individual science researcher is benefited and accelerated? Okay. So what do we think of software? We think software has become essential for the bulk of science. So Dan Katz, when he was the program officer at NSF, just did an anecdotal study by looking at recent issues of Science and found that half of them were software intensive. Yeah. So think about that. 50% of science is now being driven by software, right? There's a wide range of software types, and the important thing is it's not a one-time effort. Software products, are used for maybe 10, 15 years. Even then, they don't become obsolete. I mean, speaking from the industry perspective, the COBOL programmers are still very much in demand, right? So it has to be sustained. So now let's look at the software cyber infrastructure programs. And let me start by sort of giving you what we think of as ACI's software mission. Okay. So I'm now telling you something internal about our division. We're trying to tell you how we think about our software programs. So here's how we think about it. We think that our programs will seed. Okay. So we will start things. Okay. What will we seed? We will seed the innovative software-intensive science ecosystems. Okay, we will try to shepherd these ecosystems to sustainability. Sustainability in what? Advancing science and engineering. Yeah. In what manner? In a reliable and robust way. And how can we do this? Obviously through our solicitations and funding mechanisms, but also community engagement and outreach like the kind I'm doing now. Okay. By the way, when you read that, what do you not see? So what you don't see is, we don't say we will sustain it. Yeah? We do not say we will support things till the end of time, even if those things are critical. We don't say it. Okay? And you should keep this in mind. Okay? So, by the way, why don't we say it? It's because, essentially, if we sustain something long, NSF was created to fund discovery. Okay? It says where discovery begins. That's our mission, right? The more we fund sustaining operations, the less we will be able to spend on discovery, right? And our budgets are flat as well, right? So we are constrained by the way we've been set up and by NSF's mission to essentially act as seeders and shepherders of innovation. Okay. So how are we trying to position our software programs? So to add to that mission, here's sort of our vision. Our vision is that we will be the primary, so we will be the first agency you will turn to when you think about providing an innovative software capability to a researcher. Okay, we want to be a catalyst. We can't be a sustainer. Let us at least be a catalyst. So maybe we can make things go faster, grow more in scale. Of what? The software components of a national science cyber infrastructure ecosystem. That's what we're seeking to do. Okay. So when folks have a cool idea that will increase science time to science, or reduce time to science by order of magnitude, we want you to come to us. So we think of supporting this ecosystem in a holistic manner. So there is, of course, the software-enabled ecosystem, but we are looking at essentially 4 kinds of activities. One is the core cyber infrastructure research. You could think of it as computer science research. You could think of it as computing research, but that core research, right? Sorry, never mind. So let me start there. So there is scientific software that, modeling and simulation techniques, things like that are embodied in software. So we seek to support research in that, and then the development and deployment of that scientific, those techniques and components and so on as part of the infrastructure. We also look to fund research in infrastructure types things, the computer science, computing kinds of things, and then shepherding it into into deployment. We look to look at learning and workforce development. We look at training and education and things like that. We look to support that, and we also look to influence the community policies and essentially create the environment for nurturing this ecosystem. Okay, so we're trying to look at this in a holistic manner. Okay, so now how do our programs reflect this intent? So how do this intent? How is this reflected by our programs? So we have programs that essentially fund research and innovation, and then we have programs that fund deployment and development. Okay, so programs like the computational and data-enabled science and engineering CISE-ACI program fund the research aspects of it. The CRISP program funds the research aspects of doing modeling and computational techniques and so on to look at interdependent infrastructures. We look at the research aspects of the computations needed to fund, material science research through the MREF. So there's a whole research funding pipeline, research funding aspect to our programs. Most of these programs we don't lead, we co-fund, we support. Okay, these are led by other divisions and directors because, as you can see, the domains of research are different. Okay. We also think of computer science itself as another domain science that we support the research in. So we support programs like XPS and SPX. Okay? And then these research programs, that's the intent anyway, that these research programs serve as the pipeline for new techniques to get into cyber infrastructure and are deployed into cyber infrastructure and so on. And that, for example, we have a program that supports the development and deployment of these innovations, and that, for example, is our SI2 program. Okay? Okay. But in addition to supporting development and deployment, so the construction and transition of these techniques in software, we also would like to encourage folks to think of these efforts in a research-oriented way. So as software is being developed and deployed and put into the hands of users, we want our PIs to be thinking, for example, in a research-oriented way about things like usability, about the software engineering practices, about community engagement, all of those things. Okay. And by the way, what do I mean by a research-oriented way? I mean, you're not simply trying to solve a problem, you're trying to create generalizable insights through the solving of a problem. Okay? That's what we mean. And by the way, we also have a way to opportunistically inject funding into other projects. We call it a venture fund or a reuse fund. So if there are other research projects that are showing potential for creating reusable software, we have ways of throwing some money at those PIs and encouraging them to do so in a systematic way. Okay. So our flagship program is the SI2 program. Right? So our research programs serve as the start of that pipeline, and then we try to take that pipeline all the way through. So we have the SI2 program that starts with smaller projects, small components of what we call elements, larger frameworks, and then finally institutes that serve as focal points and hubs for an entire community. Okay, and the Gateways Institute being one. We also have a Molecular Sciences Institute being another. And the SI2 program, by the way, has some very unique criteria. So when you read a solicitation, if there is a section called solicitation-specific review criteria, read that section carefully. Okay, just a hint, right? But note that every program has different expectations, and our SI2 program has some very, very unique criteria, given that it's all about development and deployment and getting it in the hands of users and all of those. Okay, so it's criteria that other solicitations don't have. Okay. For example, the software that you create must meet a recognized need, right? It must bring innovative research capabilities into the hands of others, right? Not for your lab, but for others. We are talking about embedding research into the project activities. We are asking about a very well-defined management process that is user-engaged and dynamic. We are looking for teams with credibility in both software as well as the domain. We're looking for community engagement, we're looking for sustainability, and we're looking for projects that essentially further a national ecosystem. So things like reuse, integrate, and adopt things that are integrate with and adopt that are already out there, with things that are already out there. So to that end, given that our programs have been running now for 5 years, and this is our 6th year, here are sort of our priorities. Okay, so this whole notion of this national cyber infrastructure ecosystem is one. Yeah, using the cyber infrastructure to enable robust and reliable science. So the progression from repeatability of experiments to replicability of experiments to reproducibility of experiments. By the way, there's a progression here, and I'm sure most of you know what that progression is. If not, ask me. Things like uncertainty quantification, things like linking the computations to software publication, provide things like being able to cite data and software artifacts, trying to drive, comprehensively get education in modeling and simulation and computational thinking throughout the country. And then internally, we are looking at doing as much operational improvement as we can through continuous learning. So we're going through constant portfolio analysis. We're looking to expand our software programs to new science domains. We're looking at process improvements internally in the way even down to the way we structure panels, the way we solicit reviewers, all of those things, and we're looking to align more and to have a set of strategic goals that we make public, by the way, and try to align as much with them in our solicitations and the proposals we fund and so on. And by the way, when I talk about a national cyber infrastructure ecosystem, here's kind of what I mean. Think of it as layers. So here you have all the resources, clouds and NSF supported resources. You have probably a cyber infrastructure kind of platform that handles both data as well as computation, as well as security, authentication, workflows, and so on. And then a collection of gateways and applications and research facilities that use this. This is sort of our big picture of this. And we are thinking of each entity in a sense as being a vertical. So there's an understanding the brain vertical, there's an infused vertical, there's a facilities vertical that cuts across, that uses a vertical slice of these services. Okay. By the way, as you can see, gateways are key here. Another driver for us in the coming year will be this NSCI, the National Strategic Computing Initiative. It was an executive order from the President's office. And here are basically its strategic objectives: computing at exascale, coherence between modeling and simulation and data analytic computing, systems that go beyond Moore's law, an enduring national ecosystem, and public-private collaborations, right? The ones in red are where NSF is going to focus on, because computing at exascale, building those big machines is not really going to be our responsibility. Although I'll say this again later, basically what we think of computing at exascale is 100x reduction in time to science. Okay, so if you think of exascale computing as essentially scaling up time to science, yeah, that's what we mean. Right? And once again, remember, we are all news inspired here at NSF in ACI. So for us, it's all driven by science frontiers. So we look at our domain directors to tell us what the new science frontiers are, and we look to figure out how our cyber infrastructure can deliver 100x improvement in time to science. Okay. Very quickly, we have other programs as well. We have a data program. We have a cybersecurity program. We have a networking program. We have obviously Exceed, and we have a learning and workforce development programs that tries to inject learning and workforce development across the entire progression of the computational scientists, starting with REUs to graduate education to early career and then career programs. Okay. So finally, gateways. Okay. So how much overtime am I? I have 15 minutes. Okay, then I can actually stop and ask for questions. It's almost like walking here from the hotel.
Not a question. I just got back from Exascale Computing in China, and Irene was there. All the types of and an astounding thing was about their software strategy. What they did is they took all the software, put it on a long tail histogram, and they chopped it to like top 20 packages. Those are the things they were looking forward to, starting with MPI. My takeaway was there's no innovation.
That's correct.
It's just turning different. And so I think the fact that NSF focuses means you have an undue opportunity and responsibility to that innovation, even for software, even for exascale applications. There's probably more for innovation. They are.
And the only thing I would add to that is, remember, NSF doesn't really do anything. Right? I mean, right. Yeah, right. So, but that's what we do, right? We fund good ideas. So we are looking to the community to share those good ideas, to come forth with those good ideas, and share them with us as actively as you can, right? So that we can appropriately support them. That's what we're looking for, right? Sure. Right. So we are very aware of this. We are very concerned about it. We are trying to influence universities, which are primarily where these folks still work, supercomputing centers and so on are affiliated with universities and so on. We're trying to at least indirectly influence universities to create career paths for the folks who there. What are the kinds of things we've done? So one thing is that in your NSF bio, we now ask for 5 research products. We don't ask for papers, right? That's a huge, significant change. And we are hoping that folks whose primary contribution is not papers, but really innovative software and things like that, we'll list them there. We'll get DOI for those software and put those things there. In the SI2 solicitation, we even say things like, if you have done this kind of software development before, please cite that software, get a DOI for it and cite it there, and we'll use that in our evaluation. So that's one thing. The other thing is we've opened up the career program and soon the CRI program for non-tenure track faculty. Okay, so for research scientists, research engineers, and so on, you will be able to get early career kinds of grants. Okay, so that's the second thing. The third thing is, normally in research grants, faculty are only allowed to get PIs are only allowed to get a maximum of 2 months support over the year. For ACI kinds of things, we support more than that. So we're trying to do those kinds of things as well. Okay. Yeah. So that. But I'll come back and answer something more. But go ahead. Yeah. Right. Right. So the whole notion of convergence between those data analytic architectures and HPC architectures is driven by the fact that industry has all these innovative architectures for doing those kinds of things, and and we need to figure out a way to connect. We need to figure out how to connect those two, and we will fund. We will prioritize efforts that are trying to do that. We think that the real issue is time to science, not the innovativeness of those architectures, but how those architectures deliver time to science. So people who are thinking of doing that integration in a way that accelerates time to science will be the ones we will try to support as much as we can, right? But we're coming back to your question about career paths. One of the reasons why the SI2 solicitation says embed research within the software development is so that people who do the software development actually get research outcomes out of that effort. And there are papers on usability and things like that they could potentially publish in reasonable places, right? That could give them research credit as well, right? I know this is possible because I've done a lot of this myself. So a lot of my publications are very applied kinds of things, okay? The other thing is I think we need outlets that are well respected, publication outlets and conferences that are well respected, that are focusing on CI. So, you see, presentations around CI work at places like Exceed and things like that, but but they haven't quite reached the kind of recognition within the computing community that other conferences like IPDPS and so on have had. And I think we need outlets that are respected to that degree. And I think our community should try to create those kinds of outlets. Tracks maybe, if not entire conferences, things like that. And we'll try to support those kinds of activities. Okay. Sure. Yes. So you mean like a DOE fellow or something like? Yeah. Our role has always been to fund institutions. The only thing that's portable is, I think, our graduate fellowships are portable. They go right. So yeah. Okay. Right. 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 So the CTSC, that the Security Institute. I'll digress a little bit, and then I'll come to your point. That was set up through NSF funding to basically provide advice around security issues around scientific computing. Okay. The thinking is that this whole notion of advice and support around software engineering and software carpentry kinds of things could potentially be provided by an institute. Okay, perhaps the Gateway Institute could provide this as part of its offerings, maybe using subcontract software carpentry and things like that. Maybe this could be something that the Security Institute could be expanded to provide. We would, our PI meeting, which will be in February, we are actually now thinking of expanding that to include things like software carpentry workshops. But we need our PIs to sort of propose things like that, and then we will support it. We are thinking of including in our solicitations things like show that you have the credibility for developing this kind of software at scale by having certifications from software carpentry and things like that as well. So we can try and drive those kinds of those kinds of behaviors as well. Remember that our mechanisms for driving this are essentially funding mechanisms and then bully pulpit kinds of things, right? That's all we have to work with. It's a little bit like pushing on a string sometimes, right? Yes. 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 Right. Yes. So last year we had a hackathon at the CCAN workshop in Europe. Actually, we funded Shantanu Jha and Cecilia Clementi to do that. So we will do more of those. The thing is, how can we get long-term benefit from those workshops so that the benefit of the workshops? So what I'd like our community to think about is how we can get long-term benefit from those kinds of workshops. So it's not just the people who attend the workshops who benefit, but also there are assets created that are then widely available, or something like that would be really useful. So anytime somebody proposes a workshop like that, we've been trying to encourage them to broaden the proposal to include those kinds of things, and yes, we will support that, absolutely. Okay. Yeah. Okay, so more questions. Nancy, you had a question. Yeah, pretty much. Yeah.
I was going to ask, especially focus on a lot of time gateway communities around novel and forward by gateway. What kind of funding up sectors and going?
So the idea is, and this is kind of high level thinking, and it would be helpful if y'all could help us kind of refine it, help me kind of refine this. The high level thinking is the Gateway Institute would sort of provide advice and guidance and pointers to software, even host certain kinds of things, maybe even provide some software that you've curated and all of those, right? And folks would then use that to sort of build gateways for specific projects that would potentially themselves have separate NSF funding, right? That's kind of how we are thinking about it. Yeah. Oh, to get that kind of separate funding. So certainly any of our research programs that involve building a gateway for a certain community should talk to us, and we could potentially use, for example, venture money to seed the gateway part of the activity, things like that. Yeah. Okay. Also, any activities that would increase the capabilities of the Gateway Institute, we might be able to do things like eagers and so on to fund. Okay. So, for example, are there databases of software that, things like that? Is that what you mean? Very little. Very little. So Exceed, for example, I think was going to maintain a database of software. I think there was some notion of a repository, right? That's right. Right. And then for a while, Dan was manually putting together a website with all the software. So we don't have anything that's systematic and comprehensive at this time. Would you agree? Right. So the Gateway Institute will play a role for all gateway-related software. The Molecular Sciences Institute will play that role for all molecular sciences software. You know, as for some national database that curates and so on, all kinds of software that doesn't fit into these institutes. Well, once again, remember, NSF doesn't really do anything, right? So we look for the community to take that on, and we can try and support that, actually. So, you know, yeah. So anyway, good. Yeah, go ahead.
Can you, from your perspective, how that gateway system with a side of funding will help your developers?
Okay, sure. Can I hold that answer till I go through this? Then, because it's related. Okay. So, yeah. Okay. So most of you know all this. I can go through this in 30 seconds if you want. And so you know, there's lots of science gateways. Yeah, they're used for a variety of purposes, right? From collaboration to workflows to all kinds of things, right? Here's a great example of a gateway that has really enabled a huge ecosystem. You know, people are using gateways more and more as opposed to using bare metal, right? Command line users. Even though, Nancy, I'm sure you shed a tear when the command line started not getting used. This is an inside joke, by the way. You know, gateways enable reproducibility. So there's, you know, in addition to providing productivity tools, they have all kinds of other very important effects. They enable reproducibility, and we funded a project around that. And essentially, gateways enable ecosystems. They provide critical tools to scientists. They make complex techniques available in a usable way. They support collaborations. May even serve as the community water cooler for those of you who remember water coolers, right? They enable reproducibility. Essentially, gateways are key for accelerating robust and reliable science. So we recognize the importance of gateways. Heck, we just funded this institute. You know, please visit their booth, okay, at the expo. Right? Here are the kinds of things you know the institute can provide. But looking to the future, and if I can spend 30 seconds on this, I think 10 years from now, I think here are the kinds of things we'll have to deal with. You know, dealing with societal grand challenges essentially in real time. Okay, so the time to science has to be really fast because we need to be able to act on those results. Right? We think that research needs will become much more distributed and dynamic and multidisciplinary with a wide spectrum of stakeholders and participants. I think research processes will need to be dynamic, and so we need cyber infrastructures that support all of these kinds of dynamic activities. Okay? Gateways are a good start, and we hope to make that happen.